So today, we are going to talk about constant, power, and constant multiple rule. So the first rule that we are going to undergo is the constant rule. If f of x is equal to c, where c is a constant, then f prime of x is equal to 0. Given f of x is equal to 100, f prime of x is equal to 0. Another example for the constant rule, if f of x is equal to the fifth root of 556, then the derivative of the given is equal to 0 since it is y constant. Is equal to 5 over the cube root of 5,000. Then, its derivative is also 0. The next rule that we are going to undertake is the power rule. The power rule tells us on how to differentiate expressions of the form x raised to n. In other words, expressions with x raised to any power. So, the derivative of x raised to n is n multiplied to the constant, then the n is subtracted by 1. Given f of x is equal to x raised to 5, where 5 is multiplied to its constant, which is 1, so it becomes 5x raised to 5 minus 1. So f prime of x is equal to 5x raised to 4. For the next example, given y is equal to x raised to 1/3, y prime is equal to 1/3 multiplied to the constant of x, then 1/3 minus 1. Y prime is equal to 1/3 x raised to negative 2/3. Then, let us make it to its radical form, making 1 over 3 cube root of x squared. For the last example, given f of x is equal to 1 over x raised to 6 is also equal to x raised to negative 6. F prime of x is equal to negative 6x raised to negative 7 because negative 6 is subtracted by 1. So it becomes negative 6x raised to negative 7. For the last rule, we have the constant multiple rule. If f of x is equal to kh of x, where k is a constant, then f prime of x is equal to kh prime of x. For the first example, given y is equal to 3x raised to 1/2, y is equal to 3 multiplied to 1/2 x raised to 1/2 minus 1. So it becomes 3 over 2 times x raised to negative 1/2. So y prime is equal to 3 over 2 square root of x. Next example, given f of x is equal to 1/3 cube root of x, f prime of x is equal to 1/3 x raised to 1/3. F prime of x is equal to 1/3 multiplied by 1/3 x 1/3 minus 1. So its derivative is 1 over 9 x negative 2/3. So f prime of x is equal to 1 over 9 cube root of x squared.
So for the next example, we have f of x is equal to 1/4 cube root of x. So to get its derivative, first we're going to change it into its another form, which is 1/4 x raised to 1/3. It becomes f prime of x is equal to 1/4 times its exponent 1/3 x and 1/3 minus 1. And then it becomes 1 over 12 x raised to negative 2/3. So for the final step, we're going to change it into its radical form, which is 1 over 12 cube root of x squared. And for the last example, we have negative square root of 5x. So it becomes f prime of x is equal to negative 5x raised to 1 half. Next, we're going to multiply the constant by the exponent. It becomes negative 5 times 1 half x, and the exponent 1 half subtracted by 1. Next, negative 5 times 1 half, it becomes negative 5 halves x, and negative 1 half minus 1, it becomes negative 1 half. And for the final step, we're going to change it into its radical form. It becomes negative 5 over 2 square root of x. Now let's try. We have the given f of x is equal to x to the 4th power plus 2x cubed minus x squared plus 4x minus 1. So for x raised to 4, we're going to use power rule, and for 2x raised to 3, we're going to use constant multiple rule, and for negative x squared, we're going to use power rule. And for this one, we're going to take note that the derivative of a constant times a variable is the constant. And for a constant, always take note that its derivative is always 0. Now let's apply the rules. So f prime of x is equal to the exponent 4 times the variable, it becomes 4x, the exponent 4 subtracted by 1, plus 2 times the exponent 3, x, 3 minus 1, minus 2x raised to 2 minus 1 plus 4. And then f prime of x, it will become 4x cubed plus 6x squared minus 2x plus 4.